Welcome to your first home learning task on electricity. We are looking at electric circuits today. If you haven't already, can you have a go at the Getting Ready for P9 Electricity and Circuits quiz? It just tests what you can remember from primary school and from Key Stage 3. There's a couple of BBC bite-sized links to help you do it, and just make sure you can answer all those questions. If you've done that, then we can move on, and we'll start by looking at what we're going to be doing today. So our learning intention for the day is that you should be able to draw circuit diagrams and understand the flow of current in a circuit. What that looks like in terms of success criteria is you should be able to describe the basic structure of an atom, and you've done that at Key Stage 3 and in chemistry, so that should be fairly familiar to you. You should be able to recognise circuit symbols, so cells and batteries, switches, voltmeters, ammeters and lamps, and in fact we're going to look at a few others as well. Again, those examples certainly you should have done before in Key Stage 3. You're going to be able to describe the conditions needed to produce an electric current, and those are that there is a complete circuit and there is a voltage source or a source of potential difference, and we will look at that a little and develop that over the course of the next couple of lessons. Slightly higher level success criteria, we're going to get you to draw some circuit diagrams, understand the difference between the positive and negative terminal in the circuit symbol for a cell, and get you to describe and explain the difference in brightness of identical lamps in series and parallel circuits, and also the effects of different numbers of lamps and cells in series and parallel. And you'll get to do that by doing a little experiment using an online simulation. There's no top level success criteria for this topic, so nothing in the grade 7 to 9, which means this will come up in pretty much all papers, so this is all foundation content, but you need to know it if you're doing the higher paper as well. Key vocabulary, you should be familiar with the word atom and the components of the atom, the electron, the neutron and the proton. You should know that the neutron and the proton are in the nucleus, and the electrons orbit the nucleus in shells. Lastly, there's two types of circuit, parallel circuit and series circuit, that you'll have come across before. Not in your booklet, and I'm not going to refer to it again after this, but something for you to think about if you fancy a challenge. If you live in a house with 2 stories or more in it, you're probably used to the idea that if you're downstairs you can turn on the lights upstairs from the bottom of the stairs and vice versa. So could you design a circuit to separately control the lights up and downstairs from either the top or the bottom of the stairs in a house? In your booklet, task 1.1 is to look at the subatomic particles. As I say, you should have done this before and you should be quite familiar with it from chemistry. If you're not sure, there's a BBC bite-sized link to help explain it, so have a little look at that and make sure you can complete this table. One thing to note, in the relative mass column at the bottom there, the subatomic particle with the smallest relative mass, we don't normally give it a proper number as such, but you can say it is negligible. Make sure you can spell the word negligible, or that the relative mass is 0.0005. And the way to remember that number is there are 5 digits and the 5th one is the 5. All the others are 0. 0.0005. So have a go at completing that. Pause the video and come back once you've done it. Next task, task 1.2, is to learn the circuit symbols. I would just read through them at first, then try covering up the right hand side of the table so you've just got the lists of words, so switch, lamp, ammeter, voltmeter, and then try and draw what's on the right hand side on a separate piece of paper. Once you've done that, cover up the left hand side so you've only got the symbols, and then try and remember what the words are. What diagram or what symbol represents a switch, a lamp, an ammeter, and so on. I'll quickly run through them on the screen. You've got a switch, should have used this at primary school, should be familiar with that. We've got a bulb. Again, you probably used the symbol for a bulb at primary school and Key Stage 3. You may have used a slightly different symbol at primary school, and we'll talk about that again in a little bit actually, because the simulation we use uses the other symbol, but this is the one you need to know for GCSE. Two components we use to measure and understand a circuit: the ammeter, a circle with an A in it, and the voltmeter, a circle with a V in it. Next symbol is the cell. What we often call a battery in sort of general words, but in science a battery has a very specific meaning. It's actually several cells joined together, and this next symbol is the battery. You can see it is the cell symbol, but with two or more cells in it. To help you on this diagram, I've put a plus and a minus to show the positive terminal and the negative terminal, but they won't always be there. You need to remember that the long thin line is positive, the short fat line is negative. Next symbol is for a resistor. Resistors always have this rectangular shape to them. This is a simple resistor, so it's just a simple rectangle. Moving up to the top on the right, this is a resistor, but it is variable. This is a variable resistor, and that's represented by this arrow to show that it changes. Another simple symbol, an M in a circle, is a motor. This is probably a new symbol to you. This is a diode. You might not have come across this before. You need to know it, and you need to understand how diodes work. We're going to do that in about 3 lessons time, but for the moment you need to know that it only lets current flow in one direction. So this arrow represents the direction that the current will flow in. This line represents the fact that you can't have current going in the opposite direction. Here we have another resistor of some sort, because it's that rectangle shape again. This one is a thermistor. Like the word thermometer, therm means temperature, so it's a resistor that's dependent on temperature. When we do our lesson on diodes, we'll also look at thermistors. This symbol's got the diode shape in it again, so you know it is a form of diode. It is emitting light. These arrows represent light. It is a light emitting diode, or an LED, which you should know about. Probably lots of your electronics have got LED on them, but this is the circuit symbol for an LED. And the last one is another resistor. We've got the rectangle. This time the light is going inwards. It is dependent on the light. The resistance is dependent on the light. It is a light dependent resistor, or an LDR. So make sure you take the time to learn those circuit symbols, and when you've done so, come back and move on to the next part of your booklet. Task 1.3 is to watch a short YouTube video by someone else. They're much better than me at explaining everything, so I'm going to let them do it. Make a few notes. You'll need them to answer the quiz at the end of the section. I'm not going to show you that video again now, just have a little look at it in your own time. Once you've done that, go on to task 1.4, which is series and parallel circuits, and this time you're actually going to interact with a simulation. I've got the link on the screen here. If you follow the link that's in your booklet, or type it in, or do a search for PHET, P-H-E-T, DC Virtual Lab, that will get you to the right page. Launch it up and then watch the video to see how you're going to use that. So this is the PHET Virtual Lab. If you've got it launched on a phone, you're obviously not going to probably be able to use it at the same time as watching this video, so just have a play. If you've got it on a computer, you might be able to have them side by side. On a phone, you just press on something and drag it across. On a computer, it's a click and drag, so we can take what's labelled a battery here, it's actually a cell, and we move it across onto the middle of the screen. You can see at the end there's the red dotted circles. Those show where you can put connections, so if I take a wire, I can connect it onto the end of the cell, and you can see if I've got a good connection, I've got a black dotted circle instead of a red dotted circle. All down the left hand side here I've got a load of other components. We're only going to worry today about the wire, the battery and the light bulb. In future you'll need to use the resistor. You might want to use a switch, but you don't have to. You can keep scrolling down, there's all kinds of different components, including a dog if you want to put that in your circuit, but I won't ask you to, so we'll just go back up to the top. On the right hand side There's a few useful bits and pieces. You'll see what the show current thing does. Here you can see that we've got some electrons. They're currently not moving because we don't have a complete circuit. If I tick this arrow, it gets rid of them. I would leave them in. It's quite useful to be able to see them, to see where they're going. I can add or remove labels, but I would generally leave them there, and I would just leave that unticked for values. The voltmeter and the ammeter we're going to use next lesson, but we won't use them now, so don't worry about that. Ignore these, way too much to bother about, so that's really for A level. Down the bottom, something quite useful. If you're struggling to identify components or to match it up to a circuit diagram, you can click the circuit diagram symbol, and now everything looks like a circuit diagram. Thing to note though, as I mentioned earlier, the symbol for the light bulb isn't quite right. It's an old symbol, so we don't use that. At GCSE you need to use the circle with the cross in it, but for this you're using the circle with a wobbly line in it. And the resistor, you need to use a circle with a rectangle. You need to use a rectangle. This is a zigzag line. I'm going to go back to the real view because I think that works better personally. So if I click and drag some wires on, I can start to make that circuit that you're asked to make in task 1.4 in your book. So it asks you to put a light bulb and a cell in series in one simple circuit. There we go, I've done that, and you can see I have a source of potential difference, I have a full circuit, and so the current is flowing. If you want to make any changes to your circuit, you can click on a join and press the scissors and it will cut at that point. If you decide you don't like a component, then you can click on the wire and press the trash can and it disappears. And if you've made a complete mess and you can't understand everything and it's just got too much, down the bottom here, in the bottom right, you can press on the circle arrow and it will reset everything and get rid of everything for you, so that makes life a bit easier. If you want a bit more space, you can use this minus here to zoom out, and you'll see that now my circuit is much smaller on the screen. I can zoom back in again, although it starts to disappear. I'm going to leave it at this size because what I'm going to do, I'm going to rebuild the original circuit, and then I'm going to talk about what we said before, which was that you're going to have a few tasks to do. So here is my bulb, single bulb, and that's how bright it is. Your first task is to build a circuit with two bulbs in it, but where both bulbs are as bright as this one bulb. So see if you can play around with all the different bits and pieces and make it so that two bulbs are as bright as one. So let's put two bulbs into this circuit and see if we can get it to work. I mean, this would be way too easy if this was the answer, and you can see it's not. If you look at the length of these yellow lines, these two bulbs aren't as bright as that one bulb. I want both of these bulbs to have lines as long as this one here. So have a play around and try and make the circuit where the two bulbs have got the same brightness as the original. And once you've done that, you can turn over the page and that will tell you about a couple of the solutions. And then there's a knowledge check on the quiz. So pause the video, go to the PhET virtual simulation and see if you can work out how to make a circuit where the two bulbs are as bright as the one. Off you go. So hopefully you paused the video and have come back. If you are just letting it run, then you are cheating, and I am not very happy. However, I can't really stop you, so let's just move on. So there's two ways to make the bulbs as bright. The first one is to introduce some more potential difference. So if I drop a second cell into the circuit, and it's gone a little bit wonky, but you can see that the two bulbs are now as bright as this one. So I've doubled the potential difference, and because I've done that, I've now got both cells as bright. But there's actually another solution as well, and I'm actually going to reset and go back and do it from scratch. The other solution doesn't involve using a second cell. Instead, what you do is you put the second bulb in parallel with the first. So the circuit that we started with is in series. One component is after another. That's a series circuit. In this circuit, we've got two parallel lines running here, and so this is a parallel circuit, and you can see both the bulbs are as bright as each other. Right, so that's the solution. Go now to the knowledge check and make sure you can answer the independent learning quiz, and then you're done for the day, and we will move on tomorrow with current and potential difference.